Fractions are equivalent if they represent the same quantity, such as the physical area or whatever representation you want to use. So 1/4, right, shows this. 2/8 is still the same quantity, though, of the full square. And then 3/12 is still the exact same quantity as 1/4. So these are equivalent fractions. They're actually equal to each other. What fractions are equivalent to 2/7? Well, all we have to do is either we can just draw a diagram like this to show that. You know, you could show, right, 2/7 as a diagram like this and go 1, 2, 3, 4, 5, 6. 2/7 is just this. And then, of course, you can go looking at the same diagram, 1, 2, 3, 4, 5, 6, and then cut that in half. 4 is going to be these two and these two. And how I drew this, these two look the same. It's kind of hard to tell because I could have messed up my drawing. But a better way of doing it is to ask the question, can I multiply the top and bottom number by the same thing to get this thing here? And for this one, yes, we can. If I multiply top and bottom by 2, then I get 2 times 2 is 4, and 7 times 2 is 14. So yes, 4/14 is the same thing as 2/7. Effectively, all we're doing is we're just going to multiply by 2 because we're cutting it in half. If you cut it in half, you double the amount that you have. But you're going to double both what you, the parts that's shaded and the parts that are total. So you have to double both the top, the numerator, and the denominator. Here, instead of doubling, we cut it into thirds. So in other words, we're going to triple it. So if you're going to multiply them by 3, we do 1/4 times 3. That gives us 3/12. That's the idea here. So can I multiply this by something to get this? Well, 2 times 3 is 6. Whatever you do to the numerator, you must do to the denominator and vice versa. But 3 times 7 is 21. This would give us 6/21. That's not 6/18. So no, that cannot be equivalent. Okay. Here, 7 times 5 is 35. So we're going to do the same on the top. 2 times 5 is 10. So yes, I'll do it like this. 2 times 5 gives us 10/35. Just like here we had 2 times 2 over 7 times 2 gave us 4/41 or over 14. Finally, for this one, right, we're going to ask the question, 7 times 4 is 28. Right? Yes, 7 times 4 is 28. 2 times 4 is 8. This does not equal 8/28, which is what we should expect here. So no, that does not work. Okay, find 4 fractions equivalent to 1/5. Find 4 that are equivalent to 12/7. Well, this is very easy to do. Just multiply top and bottom by something to where you get the same thing. So multiply by 2, we get 2/10. Multiply by 3, we get 3/15. By 4, we're going to get 4/20. By 5, 5/25. 6 6/30, and so on. I could do that as many times as I want. The same thing is true here. Multiply by 2, 24/14. By 3, it's going to be 36/21. By 4, 48/28. And by 5, 60/35. These are all the exact same. I should write it like this, actually. Instead of using a comma, I should use the equal sign since they are, in fact, equal. Okay, now, since we can have infinitely many expressions or way to express a fraction, the question is, which one do we prefer? And we always prefer the simplest form. The simplest form is going to be the expression that has the numerator and denominator to have no common factors. or be completely reduced. That's what it means to be completely reduced. So the simplest form of this one, there's a couple ways you can do this. You can just keep dividing out common factors, or we can look at the prime factorization of the numbers. So here I can divide top and bottom by 2. So I'm going to take that factor out. And again, I can divide top and bottom by 2. And here, 1 is always kind of a easy place to stop, because you know that 1 can only be divided evenly by 1. There's no other factor in there. And there's no point in dividing by 1 because it's not going to change anything. And so there's no common factor besides 1 between 1 and 4. So 1/4 we say is simplest form, or is the reduced form of 4/16. It's the smallest form that shows the exact same relationship, or the exact same representation. Okay, for 28 and 54, we can look at the prime factorization if you wanted to do that. As long as the prime factorization is easy enough, or you know it, this is not a bad way of going. 54 is, let's see, it's even, so it's going to be 2 and 27. 27 is 3 and 9. 9 is 3 and 3. 28 we can actually do in our heads, because 28 divided by 2 is 14, divided by 2 is 7, and 7 is a prime number. So we're going to have 2 times 2 times 7. And we have 2 times 3 times 3 times 3. And all we have to do is cancel common prime factors. 2 and 2. There are no more common prime factors, so I can multiply this all together. That gives me 14 over 3 times 3 times 3 is 27. This is the simplest form of this fraction. All I really had to do here is just divide by 2. But the nice thing about this is that it shows you all the common factors you can cancel. You can cancel by a lot more than just one common factor, if there are them. Okay, these numbers are quite large. We could do the prime factorization of this and cancel a bunch of common factors. We can also take it in steps and divide by common things. I think it's easiest to take it into steps, because you can use a calculator to easily check. Both of these can be divided by 5. They both end in 0 and 5. So divided by 5 gives me 360 divided by 5, 72. And 495 divided by 5 is 99. Okay, 99 is, this one's actually quite easy, because this is going to be 9 times 11. 11 is, those are always easy to see for between 1 and 100, because it's always going to be 11, 22, 33, 44. So I know this has 9 and 11, and 9 is 3 and 3. So I know the prime factorization of that is going to be 3 times 3 times 11. That may not be obvious to you. If not, that's fine. Just find a common factor to divide 72 and 99 by, and keep going from there. No matter which process you do, you should always get the same simplest form, because there is only one simplest form, the one that has no common factors. So the prime factorization of 72, I can actually do this really quick. 72 is 8 times 9. 8 is 4 times 2, and 4 is 2 times 2, where 9 is 3 times 3. So this one was actually quite easy to check here, because of the kinds of numbers that it breaks up into. We have 3 and 3. And you can see here I have got 2 common factors of 3. So I'm going to cancel both of those. That leaves me with the number 2 times 2 times 2, or 8, and then 11 in the denominator. So these two expressions, or these two fractions are equivalent, and 8 over 11 is the exact same, is the simplest form of this fraction. This one actually doesn't have a simplest, well, its simplest form is easy to see, because 5 can go into 15. 5 can go into 15 and give us 3. You could, of course, divide top and bottom by 5, and that would give you 3 over 1, which, of course, anything divided by 1 is just the thing itself. So this is just 3. So 3 is the simplest form of this fraction. Okay, the next one, 40 over 72. We actually already know the prime factorization of 72. And 40, right? 40 is 4 times 10, which is going to be 2, 2, and 2 and 5. So 2 times 2 times 2 times 5. And this one was 2 times 2 times 2 times 3 times 3. So those 3 2's and those 3 2's cancel. And we get 5 over 3 times 3 is 9. 5/9 is the simplest form of that fraction. 3 over 6, I can divide both by 3 to give me 1/2. That's going to be the simplest form. I should be boxing these in. 12 over 36, this one's easy to see if you know the multiples of 12. Divide top and bottom by 12, and we're going to get 1/3. So no need for the prime factorization, just divide it by 12. You can, of course, divide by 2, and then divide by 2 again, and then you'll be able to divide by 3. That's the same thing, but 11 over 11, this one's easy to see, right? If you divide by the number itself, you're going to get just 1. You can divide top and bottom by 11 if you want. That's going to give you 1 over 1, but that's still just going to be 1. And this one, you don't need to do anything else because 0 divided by anything besides 0. 0 divided by any whole number divided by other than 0 is just 0. You cannot divide by 0, but 0 divided by anything is just going to be 0.